All right, guys, we are continuing with chapter 1 and rewriting equations and formulas, which is lesson 1.5. So here we go. So we're rewriting literal equations. We're going to rewrite and use formulas for area and then other common formulas. This exploration we're going to skip. We might do it in class. So we'll continue on. So when you're rewriting a literal equation, what that means is that an equation has two or more variables. That's what a literal equation is. And what we're doing is we're solving for one of the variables. So our goal is to get one of the variables by itself, and we'll use inverse operations to do that. So one of those common things that you'll see is solving for y, or getting y by itself. So our goal here is to isolate that y variable. So if we're isolating that y variable, we want to solve for y. We want to get everything else away from that y. So we'll use inverse operations to do that. And we'll deal with this y area last. So this whole y area, that'll be the last thing we deal with. So the first thing we're going to do is subtract 4x from both sides. That will cancel this. And then I have 9 minus 4x. I can't do anything, can't combine those because those are not like terms. So now I have 3y equals 9 minus 4x. So now I have to think to myself, okay, what's my goal? Get the y by itself. So I'm going to deal with that 3. Well, what operation is being used here? Multiplication. How am I going to undo multiplication? I'm going to divide. So I'm going to divide by 3. That'll cancel. And here I have to divide every single part by 3. So there's two ways you can write it. You can just write the entire thing over 3. Or, the way I prefer, we have 3y equals 9 minus 4x. We have to divide each part by 3. So how can I write my two answers? Well, two different ways that you can do this. Y is now by itself, so I can have y equals 9 minus 4x over 3, perfectly acceptable. Or y equals 9 divided by 3 is 3 minus 4 over 3x. There's even one other way you can write it, which some of you might be saying. If you can remember back to last year, slope-intercept form, y equals mx plus b, you might say that the best way to write it is y equals negative 4/3 x plus 3. So we have 3 different ways we can write it. They're all equivalent. I'm going to box all of them in. Any of these ways are acceptable. I would say this way right here is the best way, followed by this, and then this. But it doesn't matter, they all work. Example 2, in this case we're solving for x. So again, not a bad idea to always highlight or think about what you want to get by itself. So in this case, we want to get that x by itself. Now, a couple things happen here because there's an x here, and there's an x here, and I can't combine those like terms. So what I'm going to do is I'm going to get rid of the messier thing first. I'm going to get rid of this 5xz. Subtract that to both sides. So what am I left with? Well, that's going to cancel. Now I have y minus 5xz equals 3x. This is why I like that second method in terms of dividing here. Because now I'm going to divide by 3 to get x by itself. Divide by 3, divide by 3. Now I have y over 3 minus 5xz over 3 is equal to x. Remember, you cannot divide by 0. Division by 0 is undefined. So, in example 2, you must assume that z is not equal to negative 5/3 in order to divide by the 3 plus 5z. let's try some just solving for y, so you can try these on your own and go ahead and write those examples down, and they'll be in the completed notes that you can check on your own. So now we're going to rewrite a formula for area. So the formula for the surface area is S of a rectangular prism is V equals LWH. Solve the formula for the length L. So we're trying to get this L by itself right here. We have V equals LWH. So what am I going to do? Divide both sides by WH. By WH. And you get V over WH is equal to L. This is an example that we'll do in class. You can try these on your own, and again, these will be in the completed notes. That's it for today. Have a nice day, guys.